Hello everyone, welcome to this series of database internals. Today we will learn about properties of transaction. Before that, I would like to quickly recap what we have discussed in previous video. So let's get started. In last video we have learned about like what exactly is transaction, right? So we have learned like transaction is nothing but a set of logical instructions, and all the statements must be executed together, or none of them should be executed. So this is how we define transaction. To redefine it even in simpler terms, we have talked about like related logical statements is nothing but like collection of queries. You can say SQL queries. And when we say executed together, we can more appropriately say like it acts as a single unit of work. We have talked about it in depth, right? We also talked about like practical example of transaction where we took an example of like transferring $100 from account one to account two. We also have talked about like why this is a transactional example, like what exactly is happening behind the scenes. So let's talk quickly like what we have studied so far. So basically, if you want to transfer $100 from account one to account two, what we need to do is assume this is accountable, and there are two accounts, account one with ID one and account two with ID two, right? To understand it, let's say account one has 200 rupees and account two has 500 rupees, right? So account one wants to send $100, right? So if account one wants to send $100, account two, in that case, after sending account one must have $100, right? So first thing, we need to validate if account one has enough amount or not. In our case, it must have $100, which is $200. So this is the first step that we will do, right? In second step, what we'll do? We will deduct that $100 from account one. That will be like 100 rupees, right? This is what we are doing, like deducting $100 from account one, right? So if you see, we have deducted $100. Now we will add $100 to account two. Since account one is transferring to account two, in that case, we'll add $100 to account two. This is the state we want to reach, right? Whenever transaction is happening, either no transaction is taken place or it is taken place, it should take successfully. But what's the issue with if transaction is not in picture? What will be the issue that we'll face? Suppose these are the three queries that we need to write, like select balance from account where account ID is one. If that balance is greater than the balance that we want to send, then we want to update current account balance by decrementing $100 and then updating the account ID two with adding $100, right? But we can't say send these queries one by one to the database. How do we ensure all the queries has been successfully executed? There must be a way to tell like all this query is just one unit of work, right? Act as a single unit of work. First of all, we need to have a way to tell database that these are single unit of work and execute these query. Either execute all of them, either none of them should be executed. To ensure this, what we do is we wrap our query, like we have three query, right? Query one, query two, query three, right? We wrap whatever query we want to execute, whatever logical statements we have inside like begin transaction and commit transaction. Now it's database responsibilities to execute these queries and make them act as a single unit of work. Now these are the things that we have already discussed in really depth in previous video. I would not focus more on what exactly is transaction because we have spent enough time in previous video. Let's dive deep into like properties of transaction also. So let's start with the properties of transaction. So transaction, there are four properties of transaction basically, and that we call it as ACID. ACID is like a short form. A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. In this video, I'll be specifically focusing on atomicity. We will learn about like what exactly is atomic behavior of transaction, right? Going ahead, what we can say is we can again take the same example to understand what exactly is atomicity, right? So we have four properties, right? Atomicity, consistency, isolation, durability. In this video, we are focusing on atomicity specifically. So let's take the same example, practical example of transferring $100 from account one to account two. To do that, we already have discussed it multiple times. We have three steps. First, account one must have this $100 so that it can be deducted from account one, right? And transferred to account two, right? So to maintain that, first we need to validate, right? We need to check if account one has $100 or not, right? And we will do that by like selecting the balance from account where ID is equals to one, right? But this should act as a single unit of work. We also have talked about it, like we are going to wrap something like this and then all the queries, basically query one, query two, query three, inside begin transaction, commit transaction. Database will take care of this. What we are going to talk about is what exactly is atomicity, right? To understand the atomicity, first let's understand what is partial transaction, right? So to understand, so we have these three queries executing on the database. What if query one succeeded and query two failed, then query three succeeded? Then we run into inconsistent state because this succeeded, we get account one has $200, but the second query fails to deduct the amount from account one, and the third query succeeded. It added the amount to account two. Now the problem is amount has not been deducted from account one, but has been added to account two, and this is inconsistent state, right? We do not want that. Let's see another example of what is partial transaction. First two queries got succeeded, but last query got failed. In that case, what happens is account like money has been deducted from account one, but has never been credited to account B, right? And this is something we never wants, right? This is not accepted. That's why transaction gives properties of atomicity, which ensures these two things. So atomicity ensures that either none of the query should be executed or all of the queries should be executed. So if none of the query is executed, what we can say is nothing has happened, right? This is the initial state of account one and two, like with 200 rupee, $200 and $500, right? If query succeeded, if you can see the $100 has been deducted from account one and has been added to account two, right? Atomicity ensures either none of them, is executed or all of them has been executed, right? Now you can ask me, what if database server goes down? Like, how we will ensure atomicity in that case, right? So even if database server goes down, what will happen is, suppose query one succeeded, query two succeeded, and then this database server goes down. If database server goes down after these two query got succeeded, then in that case, whenever database server comes up, it will roll back. So what it will do is, this is the right query, right? Like selecting read statement will not impact on the data, right? Like whenever we are writing the data, that thing we need to roll back. To roll back, we have deducted 100 rupees. So whenever database comes up, it will add that 100 rupees in account one and ensure that there is no inconsistent state in the data, right? And since we were not, like when this query was performing, the database server went down. Now whenever it came back, it will roll back the right query that was executed earlier, this one, and we have deducted $100 then in from account one. So since this one failed, what we'll do is we will roll back by adding that $100 in account one and maintain that consistent state. Now you can argue how, if database server itself went down, how database will get to know, how database will get to know which query failed, which succeeded, because the server itself down, the memory will crash. Nothing is when server comes up, nothing is in the memory, right? Yeah, that's a genuine question, but there is a concept of wall, you can say, which we say as write ahead logging, and I'll talk about this in depth. That's why I have not kept it part of this video, but this is how, there are other methods as well, but this is one of the efficient way how database ensures atomicity, even in case of database failure, right? If server crashes, then atomicity ensures two things: either all the query should fail as if it was never executed, and even if it is executed partially, it should roll back. It should roll back in case of failure of even one query. Either all of them should be succeed. That is called atomicity, and this is the first property of transaction. So that's all for the day. Hope you enjoyed the video. Please leave comments, do subscribe, and stay tuned for the next video. Thanks.